RF experts based in Germany and for more than 20 years in the broadcast market. However, we are very well known at with spectrum regulators, broadcasters, also in the telecommunications, utility, and military market. We provide integrated spectrum management solutions, different planning tools, including the Broadcast One, consultancy, the digital mapping data system integration, up to the trainings. Just to mention that through our training center, in last couple of years, already I think 5,000 trainees passed through. Also, we have a worldwide presence, subsidiaries all over the world. The last one just set up in London, at the very same place where Ofcom is based. And yes, we can say that for the RF software and consultancy, LS is a market leader and the trendsetter. The presentation is touching the interference caused by LTE at the DTT systems. I will go a little bit to the history, why it happened. So you see here the broadcasting spectrum, maybe until to the year 2007, when we had a spectrum from channel 21 to 69, and with the introduction of a digital system, it promised a lot, and a lot for the broadcasters, more content. But if I can say, due to the better organization and the business models of mobile operator, the spectrum become much more affordable for them than to broadcast operators, and this is the consequence now that there are LTE spectrum in the UHF band, which used to belong to the broadcast world. Definition of the digital dividend: it is the amount of the spectrum available by the transition of the terrestrial television broadcasting from analog to digital. On the right-hand side, there is shown what is the remaining spectrum released after the digitalization, and the question is who can use this for future purposes, either broadcasters to enrich the offering or someone else. This spectrum, why it is so attractive for mobile operators? You see, it is at the 800 or 700 megahertz. It means that there are bigger cells, better radio propagation conditions, better hole penetrations, less shadow, and that's why this spectrum is let's say the most expensive at the moment and most wanted. WRC 2007, so-called, or it is Digital Dividend 1, allocation of the band 800 to the mobile services. So the channels from 61 to 69 are now used for the mobile services. Replanning is necessary in a lot of countries. And here it is the European harmonized band from 790 to 862 megahertz. So-called Digital Dividend 2, or officially it is input from African or Arabian countries, and their request due to already use the spectrum of 800 for legacy services brought to the new request that the 700 megahertz also is released to the mobile operator. And what we heard today from Digitag, most likely even the broadcasters, we requested to keep it just until the end of DSO. But the question is, what will be the request at WRC from the mobile operators? We must be ready also to and prepared that the request also will tackle maybe the lower spectrum. And where is the problem? You see now, even with the 700 and 800 megahertz spectrum released to mobile, it is really adjacent, now adjacent spectrum to the remaining broadcast spectrum. And so there is a lot of possibilities for different interference mechanisms. So we can basically see the two different mechanisms. First is that coverage probability is decreased due to the interfering LTE signal from the base station and degradation of the coverage probability. The other mechanism is receiver overloading, so it doesn't depend really on the wanted BC signal but only on the distance from the interfering LTE base station. So because of the very high level of the interfering LTE signal near the LTE base station, the blocking threshold, the BC receiver will be saturated and the sensitivity will be decreased. So there will be also loss in the end stop of the reception. For the overloading and also the interferences, we have to consider the parameters like protection ratios. So you can see on the left side for the 9 adjacent channels there are measured protection ratios from LTE base station, but also we can consider even 9 or 10 adjacent channels for the overloading. So overloading threshold, this is the field strength level. If it is exceeded from the mobile base station, the receiver will be blocked. Here we can see how much, or this is the distance of the 300-400 meter around the LTE base station, maybe for the first adjacent channel. So in case of 800 MHz spectrum, it would be channel 60. So 400 meters around the LTE base station, regardless to the field strength of the mobile signal, can take to the loss in the reception. Co-channel and adjacent channel interference. So we see that for the broadcasting, okay, if you consider that channel 60 is the highest channel in the broadcasting spectrum, and for the one of the frequency plan for the LTE, we see there is only 1 megahertz guard band between the highest broadcasting channel and the downlink of the LTEs. Or in case of 700 megahertz and the announced frequency plan that uplink will be adjacent to the broadcast, then we will also have the possibility of interference from the mobile phones to the broadcasting reception. Co-channel and adjacent channel interference. For the co-channel, there is maybe we have to consider separation distance, so that if we have in the same band services, that they have to be on the larger distances, like broadcasting, for instance, in the city, and mobile in rural areas. For the adjacent channel, it is different. There is only guard band, and we also have to take care of the frequency planning in these areas. This is one example. So if for the co-channel, if we have, let's say, mobile country like Germany, in this case, who is using a 700 megahertz band for the mobile, or we have Belgium and Poland using the broadcasting services in that area, we see there will be a gray zone around the borders in some 100 kilometers around the border. So this is also one of the aspects that must be taken into account during the planning. So one of the ways that allotments along the borders cannot be used, and additional frequency planning is necessary. Recommendation ITUR broadcast 2033 with planning criteria includes all the protection ratios and overloading thresholds for different numbers of the cases, like the traffic loads for the LTE base station and the percentage of the broadcast receivers to be protected. And there is one example recommending sharing status table which are we normally using also for our studies, and I think this is default value in our broadcast planning tool. And you can see on the left-hand side, in case of 800 megahertz, which channels are under threat. So maybe first 9 adjacent channels, all down to the channel 52. What are we doing? As I mentioned, we have also the broadcast planning tools, and so far we were able to take into account all this, but with the recent versions, we had also to continuously update the tool. So even though our tool is dedicated for the broadcast only, with current versions, and also I didn't mention that LTE and broadcast, there are completely two different worlds. So for instance, one is using ERP measure in watts, the other in dB microwatts, or also the antenna are different in different manner to the dipole or to the isotropic one. So all these things have to be also taken into account before starting working on the planning. So we also identified with the latest version the sectors and the multi-sector sites, so it is completely ready for LTE. Also some other things, we have the new sectors antennas, ERP and dB micro, then introduced all the protection ratios between DVB-T or DVB-T2 and LTE. We reference always to ITU recommendations. And then concerning the antenna, I can mention maybe that, and refer to the previous presentation, just what Luke did with helicopters. Of course, we can import the broadcast antennas into the planning tool measured by the helis. And several examples how certain countries are taking this problem into account. Let's say Germany, which is let's say less broad, which is not using the DVB-T as the main source of the TV broadcast, which has a fewer penetration, lower than 10%, but most likely around 5%, and provision 36 of national frequency band says that mobile service must not cause any interference in the broadcasting service. In Germany, the regulator is responsible for the planning of this interference. The aim is to guarantee protection of broadcasting services, and there are several rules that have to be followed for the interference evaluation procedure. The base criteria is the distance to the populated places, then channels from 60 to 52 are taken into account, and then there is maximum permissible base station power and minimum protected DVB-T field strength to take into account. What is good that only a few complaints are recorded so far, but this is due to the low usage of DDT and also the LTE stations deployed in last couple of years are around several thousands. It's totally different in UK, which is, I can say, more DVB-T or T2 country than Germany, which is using all the digital broadcasting services quite a lot. So this country really expected a lot of LTE interference to the broadcasting services. What are the rules followed in UK? That there is initial coverage probability calculated by UKPM method and broadcasting operator Archiva. Then what is really necessary is to calculate combined interference, not just of the strongest interferer or LTE stations, but of all LTE stations that might cause interference. So for this case, which we also supported, we had to do calculations at one time of dozens of thousands of LTE sectors. Then, when the final calculation, when the final coverage is calculated, two different DTT reception scenarios considered, by the way, the standard, the domestic, which is more critical with the amplifiers and where the more frequencies are closed, protection ratios applied, then and consider all channels, not only 10 channels, but all channels in UHF band from 60 down to 21, if there is found that some of the households or of the, let's say, pixels, what is the output of the tool can be affected, then they have to be somehow noticed that they can expect some interference or whatsoever. Who is responsible for that in UK? This is totally up to the mobile operator. They finance that. For mobile operator, the budget for the project was around 200 million pounds just for the LTE DTT interference problem. There is a new company. This is actually an organization of mobile operators, and what they needed also a planning tool able to calculate up to 35,000 sites and totally in automated way, and at the end to repeat that and to have the calculation result close to one of the broadcast operator.